Hi everybody, my name's Paul Young from Lancaster University. I'm grateful to the organisers for the chance to talk today about COVID lockdowns and future paths to sustainability. Putting together the talk has been a great chance for me to reflect on several different strands of research that I've been thinking about and how I might orientate them to focus on questions about what sort of future we might want as well as how we might get there. The image on this title slide is of the air pollutant NO2, nitrogen dioxide, over China from the satellite-borne OMI instrument. Clear here is the massive change in the levels of that pollutant due to the suspension of many normal activities from when China was locked down, comparing the image on the left to the image on the right. The broader effects of the COVID pandemic have certainly got many of us thinking about the future and what's possible, particularly having seen major changes to our lives and the economy happen on such a short timescale. But let's not forget the bigger context we're working with here. Despite any short-term changes, we are facing severe environmental problems due to human activities, from catastrophically bad air pollution in some of our fastest growing cities, to the global effects of climate change, whose impacts are reflected in the growing threat from fires, as well as integrated year on year in worrying trends in the Arctic sea ice. So overall, my goal with this talk is to provide a 30,000 feet view of COVID impacts and future sustainability, encouraging those of us who are environmental scientists to recognise the wealth of literature and ideas that are out there and how we can benefit our research when we think broadly and collaboratively. The subject is vast, and I will necessarily restrict myself in the number of examples I talk about as well as the depth I explore for each issue. Nevertheless, I hope it all provides a good basis for the discussion. And also just to say that this is a pre-recorded talk, and I hope I've not trod too much on the toes of those who've came before me in this event. I've divided the talk into three broad areas. So first, I'm going to give a brief review of some of the things that we've learned from COVID lockdowns in terms of environmental science. It will be brief because you will have heard about this from the other talks today. Secondly, I'm going to consider how recent events have got us thinking about what could be in terms of a sustainable future, before leading on to what I think we should be thinking about if we want to actively be researching in this space. Finally, I'm going to give some views as to what we as environmental scientists might do to help us better contribute to the building back better conversations. I will also note that most of my examples are UK based. Before I begin, I want to particularly acknowledge these fine people here who were generous enough to give me time to discuss their work and research in areas relevant for the talk. It includes my colleague, Professor Rebecca Willis, Will Bradley at Transport for London, and two members of my group, Tom Pinder and Doug Booker. Tom's a data scientist and Doug's a social scientist. You can follow them on Twitter with their handles as indicated there. I'd also like to acknowledge my many Lancaster colleagues with whom I've had excellent and productive conversations and collaborations over the years, not least the rest of my research group and fellow members of the different university research institutes I've been involved in. Okay, let's begin with a quick overview of what we've learned about COVID and lockdowns through environmental science and collaborating disciplines. For me, one of the clear successes has been the role of aerosol scientists in elucidating some of the transmission pathways for a coronavirus. In particular, there's been a heroic effort, I think, in understanding how the virus can be present in the smaller droplets, aerosols, that we produce through normal breathing and talking. This is especially in unventilated areas where these aerosols can remain suspended in the air for very long periods, unlike the classic droplets from coughing and sneezing, which only remain airborne for seconds and which inform things like this 2 meter or 6 feet rule. So this is a huge story, and I can't do justice to it here, but these scientists highlighted at the top, Lindsay Marr, Kimberly Prather, Kathy Noakes, and Jose Jimenez, are all on Twitter, and I encourage you to check out their work. And what's also been interesting here is their contribution to the public discourses and policy advice around the need to wear masks indoors and how we need to prioritise ventilation. And I think what's also interesting here is how the dynamics have played out between a sort of a contested and evolving evidence base and how that has interacted with science policy. And those are themes of which I will come back to a bit later. However, a major focus for environmental science, or at least atmospheric science, has been the impact of the reduced activity during lockdowns on emissions of air quality and climate pollutants and the knock-on effect on atmospheric composition. It's provided a natural experiment where we can test our understanding of the processes which link our activity to pollutant emissions and then, via atmospheric chemistry and physics, to atmospheric concentrations of these polluting gases. One particular pollutant for which it's been especially clear is NO2, whose emissions are well correlated with vehicle transport sources. In the figure on this slide, Chris Keller of NASA and Matt Evans of the University of York have demonstrated that across different regions, the reductions in NO2, as observed by satellite, are strongly correlated with reductions in economic activity, as determined from the GDP change. Given all the complexities inherent in relating economic activity to atmospheric pollution, the simple relationship that has emerged from this analysis is perhaps surprising, I think, but it is nevertheless useful in that it gives a quantitative framing to the potential costs of tackling air pollution, albeit if we do it in a completely unplanned emergency kind of way. We can also turn to colleagues skilled in state-of-the-art data science approaches to address questions about how NO2 has changed. And here I'm showing some images produced from the work of my student Tom Pinder, where he's built a machine learning model of hourly NO2 concentrations from the UK measurement network. And he's filled in the gaps in between the measurement stations by simulating how the NO2 field would vary by location, assisted with other covariate information such as land cover. And Tom's work is very thorough, and it also appropriately accounts for uncertainty in the statistical model and the underlying data. So in the figure, which also accounts for the effect of weather variability, we can see that there's a progressive reduction in NO2 concentrations, as highlighted by the lightening of the pink colour. We go from the week before lockdown was declared, and lockdown was declared on the 23rd of March, through to the first 4 weeks of the lockdown period. To unpick this and describe this more fully, of course, would be its own talk, which Tom would definitely be the best person to give. However, here I'm showing it as an example of what can be achieved through working with others whose skill sets are complementary to our own. And this is another theme of which we'll be coming back to. So I've showed two examples for NO2, as the impacts from changes in its emissions are one of the more obvious manifestations of the impacts of lockdown on the environment. However, as an atmospheric chemist myself, I should remind us that NO2 will not be the only pollutant affected, and also that the chemical and physical processes at play in the atmosphere are very complicated. These points are nicely articulated recently by a group of US scientists who had a paper in Nature which included this diagram. And I'm not going to go through this in any detail, but it outlines the several key atmospheric processes and their potential complex interactions with concentrations of other pollutants, which all go on to be important for the concentration of ozone and the concentration of particulate matter, as well as NO2. And ozone and particulate matter are two other absolutely key and important air pollutants. So for those of you who've not seen it, I do recommend this article by Kroll et al. And it's well worth seeing, so you can appreciate some of the complexity in this space. So let's take the example of tropospheric ozone a bit further. And here is some analysis of measurement data, which has shown that ozone concentration has increased at many urban locations during the reduced activity during lockdown. And this is because in these areas, an important chemical process is the direct reaction of ozone with NO2, which, as we've seen, NO2 was reduced in concentration because its emissions decreased. So here, this is some analysis completed by David Carslaw from Ricardo in the University of York. And what he's done, it's quite complex, but essentially he's quantifying the accumulation of additional ozone that appeared during lockdown compared to a counterfactual world where lockdown didn't happen. And David's written two great blogs about this that you can see on the Ricardo website, and I recommend that you Google and search those out, so that's something that you're interested in. Okay, so while we've seen that reductions in NO2 results in ozone increases in urban sites close to where those NO2 emission sources are, the same isn't true when we consider the rest of the atmosphere. Ultimately, NO2 is required to make ozone photochemically in the lower atmosphere, the troposphere where we live. And so we expect that reduction in NO2 will reduce ozone levels when we integrate it over the rest of the world and the whole troposphere. This is important for climate because ozone is a greenhouse gas. Model calculations have illustrated these reductions including the example shown here from James Webber and colleagues from the University of Cambridge, where they've explored the impact of different estimates of lockdown emission changes on atmospheric composition and climate. And I also recommend that you check out their paper, which obviously includes a lot more detail. A similar result was found by Piers Forster et al., which will be talked about by Chris Smith in the following talk. Overall, though, the studies that have explored the impact of lockdown-driven emission changes and composition changes on climate have found that the effects on climate themselves has been negligible. Perhaps another way to think about this is to remind ourselves that the concentrations of carbon dioxide, CO2, have still continued to increase. And this is shown by this figure on the right, which is the annual cycle of CO2 concentrations measured at the very famous Mauna Loa Observatory in the middle of the Pacific. And we might expect actually that the CO2 levels this year for 2020 would be about 2 parts per million higher than they were in 2019, which was higher than they were in 2018, 2017 and 2016. So, despite what we might perceive as a massive change in our activity level and the way we go about things, this really has not had a knock-on effect that we can see in our CO2 concentrations. So while the climate impact has been small, we have seen positive impacts on air quality and other parts of the environment as well, actually. So perhaps a positive message we can take from the changes that were made during lockdown is that we have been reminded that the future is not completely set, and we, as the world, can make choices about it. The possibility space has been opened. So next, I'm just going to talk through a couple of brief examples of where people have been thinking about that possibility space. So one of the major impacts of lockdown has been to make us think about how we get about. This is both from the pleasure, I think, that many of us took from the quieter streets and less polluted streets that we saw in the spring, as well as from the necessary shift to walking and cycling from public transport, such that needed to be done so that public transport wasn't overcrowded. And the benefits of a shift to a more active modes of transport, like walking and cycling, has been clear for many years and include health and well-being benefits, as well as arguments around sustainability. So, for example, since lockdown, Transport for London have completed about 80 kilometres of bike lanes, including one at this huge Park Lane roundabout in West London, as I'm showing in the top photo there. So such a comprehensive bike lane building activity would normally take many years and many millions of pounds, but this was completed in 6 months and on a comparative shoestring budget. And there are other political issues around that which I'm not going to get into. So the issue is now that the TfL, they used emergency powers under the Highways Act that would normally be used to dig up roads in the event of a gas or water leak in order to install these bike lanes. And what this means is that these new lanes are temporary, or at least officially temporary, and they need to be reviewed and approved through a more consultative process in due course. So there's a question of whether they will remain, basically. We are seeing pop-up bike lanes in many other locations outside of London, such as ones of this bottom photo, which I took in Lancaster. So I think, as with London, they do align really well with local ambitions, both from people and from local government, towards sustainable transport and more active modes of transport. But they do sometimes face multiple hurdles of not being liked by residents, businesses, drivers, or actually even cyclists sometimes. So other transport changes have included blocking off rat runs in order to keep residential areas free of cars, and these have been particularly trumpeted and evident in various London boroughs, which some of you might have seen on the news. And I say, notwithstanding reservations and protests from some, they have been a great model of successful outreach and consultation. There will be knock-on impacts, though, for the main roads, which will see an increase in traffic and probably pollution. And there's an important environmental justice issue there, since the people that tend to live along those main roads are typically less rich than those who are living in the quieter back streets. Perhaps one of the most celebrated, or at least most discussed, impacts of lockdown is the large shift towards home working. And we can imagine the multiple positive effects for sustainability, even just related to reduced commuting, as well as all the other work-related travel. I certainly don't miss the idea of spending 6 hours on a train for a day to attend a 2-hour meeting. And for academics and perhaps other similar jobs, there's also been a reflection on the amount of and need for international travel to conferences. And the figure to the right explores this a little bit, and it shows about how incremental adjustments to how the huge American Geophysical Union, AGU conference, could be organised in ways that might reduce its carbon footprints, taken from a paper by Milan Kloer and colleagues that appeared in Nature recently. And what they've done, they've calculated changes for a comparatively small move of the conference from San Francisco to Chicago, which would save about 12% of the emissions, to moving to a regional hub model where you've got it in Chicago, Tokyo, and Paris, and that would save about 79% of the emissions. Also, if we include that there's some virtual participation as well, to a more radical move to moving the conference to be completely online, completely virtual, and that would save 99.9% of the emissions. I think there are still some unanswered questions on this about how to facilitate participation of colleagues from the Global South, say, as well as finding ways to ensure that early career scientists can benefit from growing their research networks, certainly in a manner that us more longer in the tooth scientists were able to do earlier in our careers. I say, moreover, this general move to home working raises other questions as well, perhaps concerning the footprint of the technology that we use, including our use of the internet and data centers and the power that requires, as well as the energy to heat our homes, that certainly in the case of my home is going to be less well insulated than a modern office. There's also questions of our exposure to indoor air quality, poor indoor air quality, which could increase, again, depending on the nature of the homes and the activities that we do. I mean, that's certainly a massive knowledge gap. But I think we also need to think more inclusively. I think any fantasies and discussions about increased home working are not going to be relevant for everyone, and actually skew quite heavily to those in upper income brackets, who of course hold the power and social capital and can dominate these conversations. The plots below are taken from a survey conducted in May this year by the Resolution Foundation. This is a UK think tank that focuses on issues around work, income and life in the UK. The left plot clearly shows that proportion of people who were home working at the time of the survey grew monotonically from lower to upper incomes, and this clearly reflects the nature of the work that dominates in these different income brackets. And actually that also relates to the differential risk of exposure to coronavirus, i.e. lower paid people, perhaps working in shops or working on buses. They're working at these jobs that cannot, proportionally at least, in these jobs that cannot be done at home, and meaning that they're much more likely to come in contact with other people. Additionally, the plot on the right shows that it is those of us who are richer in the upper income brackets who expect to be able to continue working from home in the future. So, the bottom line here is that any kind of our envisaging of what a future must be, we need to kind of think a bit more broadly. I'd also extend that a little bit further. I mean, the impact of the pandemic has meant that many people have lost their jobs and found themselves without an income, or else they might have been elderly and vulnerable and had to isolate themselves away. And what we've seen, both cases of this, has meant a massive demand on services like food banks. And the data that I'm showing here from the Morecambe Bay Food Bank, where my amazing wife is chair of trustees. And this clearly illustrates the year-on-year growth in demand for emergency food parcels between 2019 and 2020, as we can see on the left, as well as the massive throughput of stock that happened in 2020. You can see, the huge weight of food that went out of the food bank compared to what was actually being donated. And luckily, that shortfall in the food was met through a partnership with Lancaster City Council. So all in all, I think we should be very careful about how we might talk about silver linings coming from the pandemic and our response to it. To me, it's very clear that while there are aspects of our response that we might want to continue, it's not an equitable blueprint for a sustainable future. Okay, so let's maybe turn to think about how we might approach building an equitable and sustainable future. So first, I want to talk about how environmental, or more specifically actually climate scientists, normally approach thinking about the future, at least in a very naive, cartoonish kind of way. It's a bit of a straw man, really. So typically as climate scientists, we might be presented with a range of scenarios of greenhouse gases and air pollutant emissions, which are derived from socioeconomic storylines, which are in turn underpinned by integrated assessment models. And we feed these emissions into our climate models, which then solve the physics and chemistry to produce projections of climate changes for the different scenarios, temperature, rainfall, etc. And then the output of these climate models may then be further analysed or used in impact models, such as models to describe human health impacts from extreme heat or crop growth, etc. And then the output of these impact models may then go on to inform different policy choices. However, I would contend that there is more going on than we typically realise, or that we perhaps even want to acknowledge as scientists. The scenarios that we feed into our models normally represent a very particular way of approaching the world, and normally it's one where the economic status quo is hardly questioned, so it's always about continued exponential growth of the economy. And there might even be geographical biases, assumptions and prejudices baked into these codes, and that might be how different regions are defined, the comparative relationship in size, or whether they're even represented at all, as well as how these regions might interact with each other. Moreover, you've got funders who are perhaps pressured by governments or even from views of their own leadership, who've got particular preferences for project types. And for instance, I've seen numerous talks from senior UKRI people about how we should be researching solutions which can basically enable the economy to continue as it is now. And very seldom do I see them talk about structural changes to society as a type of solution. And finally, we might also think about the broad science environment that we ourselves operate in and how pressures related to seeking surprising results, to getting fancy journals and other measures of prestige and promotion can all play a role in the way that we go about our science. So look, I'm not looking to make broader points here about realist and social constructivist approaches to understanding science. And I realise I'm probably more sympathetic than many other scientists to the research and tenets from science and technology studies and critical social science disciplines. But I am saying that we as scientists should be aware that we're not operating in anything like a wholly objective system, that our work is influenced through two-way interactions with society, including all its peccadillos and small and big P politics. Okay, so what other approaches might we consider if we were to be mapping out a sustainable future? So one famous example is Kate Raworth's concept of donut economics, which is shown in the picture here. And this envisages a ring donut, that represents a safe operating space of humanity, as it's so called. So inside this ring, in the donut's hole, this is where people do not have access to the basic requirements of healthy and peaceful lives and food and education, for instance, and for where they need to be lifted out from. And outside of the ring, that takes us beyond the boundaries of the planet, the biophysical boundaries that would make the planet suitable for human habitation. And there are severe consequences, as we know as environmental scientists, if we exceed those boundaries. So I think this is quite an intuitive model, a way of conceptualizing it. And but at the same time, I think it's actually quite revolutionary compared to the way that things are typically done, and especially is the fact that it does not place economic growth at the centre stage and looks to prioritise human well-being and planetary health. And this is the focuses like this are the subject of many people actively researching in this area. And I highlight here Julia Steinberger includes her quote, which is very relevant to what I said before. And I also encourage you to look at some work that she's recently been involved in, where they've developed a bottom-up human well-being optimized scenario, which is in a paper Millward, Hopkins et al. In Global Change Biology. And Julia's also written some other things I think which are very relevant for us to consider, and written about research into what level of consumption meets our needs, and that we should embrace the need for us to embrace a broad coalition of people who know about social, institutional and political factors. And again, just to quote her very briefly, climate research is no longer just a matter of identifying cost-effective mitigation measures. It must expand the solution space to social policy, action and activism as well. In this regard, embracing a well-being orientation directs us towards understanding how human needs can be provisioned equitably and sustainably within biophysical limits. This involves exploring lightly trodden research paths. Which are the most important satisfiers of human needs? What social, economic, and technical conditions are necessary to put them in place? And what possibilities exist for these needs to be met in a low carbon way? I think beyond embracing other expertise, anyone like me who believes in democracy should be looking to include the wider public in any envisaging of the future. And one successful way of doing this, I think, has been the UK Citizens Climate Jury, where people were invited to be part of a body that would hear evidence from different stakeholders and experts and then come to a view about what could be done to confront the challenges of climate change. I think activities like this can be attractive to governments in that they outsource difficult decisions, or they can be used to tackle issues that elected representatives might not feel confident in championing themselves due to their perceptions, real or imagined, of what their constituents' views might be. And I've highlighted just two statistics here from a recent report that the jury is considering about the Building Back Better. And the numbers highlight the percentage of the jury members who either agreed or agreed strongly with these statements as written here. And there basically is about what the government's response should be post-lockdown. And the bottom line is that the jury members all agree that the government needs to consider the climate very strongly as it confronts the tasks of rebuilding the economy. Beyond involving the public in consultation, there's an extensive literature about building projects with an active participation of communities and publics. And one model or heuristic is that of post-normal science, which was developed in the early 1990s. This imagines that for some issues where famously the facts are uncertain, values in dispute, stakes are high, and decisions urgent, an extended peer community and extended facts are needed to supplement scientific expertise in order to successfully address the problem. Extended facts are not what we would now call alternative facts, but instead they might represent information that might not otherwise be collected as part of a routine scientific inquiry. So, for instance, this could be self-reported symptoms that coincide with pollutant releases from a nearby factory. There's one example I can think of that I've heard people talk about. I mean, suffice to say, again, this subject is huge and it would need its own talk or even its own lecture series, but I think the important take-home message here is that there are years of research in this space, that if this is something that you're interested in, do familiarise yourself with what's out there. Okay, I want to finish up now with some thoughts and steps that we as environmental scientists should take if we wish to play a role in building back better. So how can we get there? Really, it's how can we as environmental scientists help to get there? It will come as no surprise that I'm basically recommending that we as a community need to broaden the base of disciplines that we work with and think more about the communities that we want to serve. And for me, I think this means going beyond the perhaps more familiar interdisciplinary projects with other scientists, other natural scientists and quantitative social science towards making connections with critical social sciences, art, design and humanities. I think typically, often when we talk about interdisciplinarity, we might even refer to me working with an ecologist as interdisciplinarity, or even me working with a land surface modeler. And I think that is interdisciplinarity in a very strict sense, but it's also quite easy. We both kind of think and conceive about the world in a very similar way, and that gets harder as we move away, as I'll illustrate in a minute. Anyway, the books here I've listed are from this kind of broader area of critical social sciences and arts and humanities and things like that. So I've highlighted here some there's books on participatory methods that have been developed within art and design, so you can include communities and in any decisions and designs of projects you might want to do, what we might now call co-design. There's also about science at the intersection of policy, policy at the intersection of science and society, particularly this idea about how politicians feel that they can use science, or where they feel confident that they can even say something about climate change and it won't offend some of their constituents, and how that dynamic works. And also, finally, in the bottom right there, an analysis of how scientific expertise and society can rub badly up against each other, particularly when goals and motivations are different. So the example that book talks about there is scientists who are working on behalf of an organization who had a factory which is polluting, compared to the local community who felt they were being negatively impacted by it. I totally appreciate as well that this is easier thing to say perhaps than to do. I've got a project, one of the projects I'm working with at the minute, where I'm working with statisticians and computer scientists. I think initially I might have expected this to be easy interdisciplinarity, but often we're coming up against issues of language, goals, and priorities, as I've sort of cartoonishly illustrated there. And then when I take that to my experience of working with my critical social science friends, this can get harder still, and sometimes actually can feel quite esoteric. But I think perseverance and respect can lead to really fascinating opportunities and projects that are definitely greater than the sum of the parts. It's definitely worth something seeking out. And here, this is my point. My points I want to get across here, that there are some practical steps that if this is something that interests you, I think there are things that you can do to sort of to build your connections, to strengthen your connections across the disciplines. You can start small by expanding who you're following on Twitter, and then if you're at a university, an institution, you can start talking to people who are outside of your faculty. Maybe involved in another research institute or another bit of the university. You can also research about what's going on locally. What sort of activities are being organised by local activist groups or interest groups, or even amongst local political groups. I'd also say if you're in a position of power and you have the opportunity to maybe think about what funding priorities should be, I encourage you to revisit what I was talking about earlier. That it's not just all about technical solutions so that we can maintain the status quo. Let's think about ways that we can fund projects that question the structures of our society, and more importantly, even fund projects which tell us how we can get to the future that we might want. And let me just also add a kind of an addendum here that I am an evangelist for the power of broadening one's disciplinary circles, but I'm absolutely not want to diminish the importance of basic science or even basic social science and basic humanities research, which has to inform and underpin any interdisciplinary project or even transdisciplinary project. Okay, so my final slide. I want to point out that I'm not alone in my calling for an approach to global futures that embraces a broad range of disciplines, and this is a fantastic article from Noel Castry, a human geographer, and his colleagues that makes more or less the same arguments I've been putting forward in this presentation. I think as environmental or earth system scientists, we're pretty well versed and practiced in nuance and complexity that comes from the physical systems that we're very used to studying. And what I'm advocating here is that we continue further down that path and embrace the additional nuance and complexity that comes from disciplines and lines of inquiry that we seldom engage with. Okay, thanks for listening. I'd welcome your questions.